What is operator overloading in C#? Operator overloading in C# allows you to redefine or overload most of the built-in operators which are available. This means that you can change how the operators work with your custom types. And it is a way to make your objects interact with each other using these operators, making your code more intuitive and readable. So let's start with some code examples that demonstrate how we can use operator overloading in C#. In order to demonstrate how operator overloading works in C#, I'm going to create a class called box. We're going to see how the equality operator works by default, and then we're going to overload it. So let's start with that. I'm going to go public class box, and I'm going to add the properties, which are going to be the length, GTH, and I'm going to go width, and the next one is going to be height, and we're going to add the constructor next. So let's go int length and int width and int height, and we're going to go length equals length and width equals width and height equals height. Okay, when you have reference types, by default the equality operator compares the references of the objects, which means that if I create two objects with the same properties and we use the equality operator, they should not be equal. So let's demonstrate that quickly. I'm going to go box 1 is a new box. Let's make this simple, 1, 2, 3, and I'm going to have my second object, which is going to be box 2, and then I'm going to go bool equals box 1 equals box 2, and now let's print the result to screen. Console right line are equal, and this should give us false. So let's run the program, and as we see, the result is false. And now I'm going to overload the equality operator. So when two box objects have the same volume, they are equal. So let's do that next. Let's create our volume calculating method. It's going to be return length by width by height. And now we're going to overload the equality operator. Let's put it here, overload the equality operator. And we go public static bool and let's make this A and B. So I get A volume equals B volume, and obviously we're going to return this. Now you can see that we get an error which says the matching inequality operator must also be defined. So let's do that next. Overload the inequality operator. So we're going to go, let's just copy this to save some time, and we're going to go is not. Okay, now we have overloaded the equality and the inequality operator. If the two objects have the same volume, they should be equal. So let's test that quickly. And we can maybe just swap this around a little bit. So let's run our code. And you see that we get now that these two objects are equal. Why? Because when you multiply the, what was this one? The length and width and height, which is 6, and this one for the second object is also 6. So these two objects have the exact same volume, which means that they are equal since we overloaded the equality operator. The equality operator is actually defined in the object class, but behaves differently for the value types and the reference types. As I mentioned earlier, for the reference types, it actually compares the references, and for the value types, by default, compares their values. If we leave our code as is, you might get some unexpected behavior. So what normally you need to do is you need to override the equals method and the get hash code methods. So let's do that next, and I'm going to explain why. So let's override the equals and get hash code methods. So let's do that. We go public override bool equals, and we need to see when we're going to return false if the object is null or the get type is not object. Get type, we're going to return false, and we're going to go box B is our object to return, and again we're comparing the volume. So okay, so we overrode our equals method. So let's do the same with the get hash code. Public override get hash code, and we're going to return volume get hash code. So now let's explain why you might want to do that. The equals method is actually used to determine if the two objects are equal. And since we already overloaded our equality operator, we need to make sure that the equals method compares the two objects the same way and is actually consistent with the equality operator as well. And since many collections in .NET, such as the hash set or the dictionary, use the equals and the get hash code methods to determine if the two objects are actually unique and to handle collisions, if you overload the equality operator but don't override the get hash code and the equals methods, the objects might behave quite unexpectedly in collections, and this is why it's a good practice to be consistent and override the two methods, the equals and the get hash code, and is also good for framework compatibility as well. Now let's create another code example. Let's assume that you're working for a bank and you need to code a software which flags any transaction that is greater than $1 million, but your bank allows transactions in 3 different currencies, and you need to create a software which actually checks each transaction, and if the transaction is greater than $1 million, you need to flag it, and then the bank is going to examine it in order to prevent money laundering and fraud and so on. So let's see how we can do that and use operator overloading as well. So first I'm going to create a enum which is called currency, and it has only 3 values for now. Let's make it USD and the British pound and Japanese yen. So these are the currencies that your bank allows. These are all the currencies that the transaction can use. So we're going to use them, and I'm going to create a decimal which is called amount, and it's going to be get, and then we're going to have the transaction currency in our class, which I didn't. Class transaction, and this is obviously amount, and we're going to go public currency transaction currency. Again, we're going to have a get only, and we're going to keep our exchange rates in a dictionary. Obviously, this is a simplified example. In a real-world application, the exchange rate is going to be updated in real time by using some external API from your central bank or whatever. So let's create our dictionary. It is going to be private static dictionary, and we're going to have currency and decimal, which is going to be our exchange rate, and we're calling it exchange rates, and it is equal. Okay, so let's go currency. USD is obviously 1, and let's copy this. So it's going, the British pound is, let's make it 133, and the Japanese yen is 0.0091, and we just assume exchange rate, okay, 133 0.0091, and this is our simplified exchange rates in USD. Simplified exchange rates in USD. So next we're going to create our constructor, and it is going to be decimal amount and currency. Currency, and we're going to set the amount to amount, and we're going to set the transaction currency to our currency. And now we need to create our method which converts the amount to USD. So we're going to go public decimal to USD, and we're going to return amount times what was our dictionary called exchange rates, and we need to pass the key, which is transaction currency. Okay, and now we need to overload the greater and the smaller operators to compare the transaction amount to USD, since we need to flag all transactions that are actually greater than 1 million USD dollars. So we need to do that next. Overload the greater operator, and let's do that quickly. Again, we get public static bool operator, and we need to pass the transaction and the amount in USD, and we need to overload the smaller operator, and we're going to return transaction to USD greater than our amount, and we're going to return the transaction USD smaller than our amount. Okay, we have created our transaction class, currency, amount, transaction currency, exchange rates. We overloaded the two operators, so let's see how we can use this transaction class in our code. Let's make transaction T1, equals new transaction, and we're going to make this 800,000, and transaction currency is going to be British pound, and the transaction, okay, the transaction T2 is going to be, how many is this? 1, 3, this is going to be quite a bit. Let me figure it out quickly. 1, 2, 3, maybe. In Japanese yen, and now we're going to check if the two transactions are actually greater than $1 million or not, so let's do that. Boo. Do we need to do, we plug transaction 1, T1, and it's equal, T1 is greater than 1 million, and do we need to plug transaction 2, this was very bad, let's change this actually to T1 plug, maybe it is a little bit better, and T2 plug, and let's print this to console, right line, and let's put them together. Transaction 1 is flagged, transaction 1 flagged. We're going to do, and transaction 2 flagged. We're going to use our T2 flag variable, and let's run our code with these two transactions and see if they are going to be flagged or not. And both of them are going to be flagged since they are over $1 million, so let's make the second one smaller. This is, what was the exchange rate? Let's run it one more time, and you can see now that the first transaction is actually flagged and the second one is not, since the amount in Japanese yen is actually smaller than $1 million US. And this is how you use operator overloading in C#. That is all for today. If you like my videos, hit the like button, subscribe to my channel. Thank you for watching.